Dear students, welcome to CR's digital classes. Today's concept is mean for continuous data. So let us discuss continuous data mean. So for continuous data, we have three different methods: direct method, then shortcut method, and step deviation method. So first, let us start with the direct method. Mean already we know it's an average. So sum of the data divided by its total. But based on the different type of data, we'll go for calculating with different methods. So now for continuous data, let us discuss. So direct method, these are the steps. You have to take midpoint first, midpoint of each class interval, and denote it as m. So we'll take an example, we'll discuss over there. First, let us see the steps. So first step, we have to frame the midpoints. Class intervals they'll be giving. We know that in continuous data, always they'll specify class intervals. We cannot further go with class intervals directly. So we'll frame midpoints. We need exact 1 point so that we can proceed with the formula. So first of all, we'll calculate midpoints for that. That is your step 1, framing it as m. M is equal to mid values. I'll explain in the problem. Mid values formula is m is equal to lower limit plus upper limit by 2. So in the class intervals wherever we have, at that time we'll check it out how that formula goes on. So next step is multiply the value of each midpoints with their corresponding frequency and denote it as fx. So we know in continuous data, class intervals as well as frequencies also they'll specify. So that particular frequencies we have to multiply with mid values, that is denoted as fx. So midpoints we'll consider, right? Just now we have said midpoints we'll consider that particular midpoints, multiply with frequencies, you will get fx column. So next step is obtain the sum of fx column and denote it as summation fx. So next step what we will be doing, whatever multiplications just now we have done f into x, that particular column we have to add up, and whenever we'll add the data we'll call as summation, right? So symbolically summation fx. So summation fx column just now we have obtained. Next step 4, divide summation fx by total of frequency column, that is capital N. So overall total you have to do frequency total, and that should be divided for the particular step 3 column, that is fx column. Now now go for the formula, that is x bar. We know notation of mean is x bar. So x bar is equal to summation fx by n is your formula. Summation fx and by n, how to obtain that, again we'll check it out using an example. So let us go for an example. Explain how arithmetic mean is calculated for continuous data with an example. From the following data, compute arithmetic mean we have. So check it out the data how it is. Marks they have given marks. So 0 to 10, 10 to 20, 20 to 30 they have given, isn't it? That means it's a continuous data. Class intervals whenever they'll specify, that particular data will call as continuous data. So they'll not specify in exam that is continuous data or discrete data. By seeing the question we have to know that it is whether it is discrete, continuous or individual. So individual, discrete already we discussed. Now let us go for continuous. So whenever they'll give class intervals, in the sense like range, upper limit, lower limit, they'll give 0 to 10 is the range. Like that data, if they frame, that particular data will call as continuous data. For that we are discussing steps. So this is the identification that marks they have given 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 they have given, isn't it? So that's what is your continuous data is about. So in continuous data, they'll give some class intervals, that is marks becomes your class interval. Then number of students they have given, check it out. So that number of students are the frequencies. So both the columns they'll be giving. Now let us go for the solution. Whatever the steps just now we discussed, that all let us do in this particular example. So check it out how the table has been framed. First column, marks column, 0 to 10, 10 to 20. Whatever the question they have given, make it as first column. Then the second column is number of students, F column. Then add up all the data, that becomes your capital N. Just like in discrete data we have done already, capital N means adding up all the frequencies. Similarly, here also add up all the frequencies values. 8 plus 10 plus 20 plus 30 plus 25 plus 12 becomes your capital N. No, total number of frequency is your capital N. Done. Next, let us go for midpoints. Midpoints, as now I said, upper limit plus lower limit, if you add up and divided by 2 you do, that becomes your mid values. Generally midpoint 0 to 10, what will be the mid value? Obviously 5 becomes the mid value, right? Now formula wise also the same. What we'll do, this is called lower limit. Check it out here. This is 0 is called lower limit and 10 is called upper limit. So upper limit, lower limit, both you add up. So how the data goes on, how the formula goes on, check it out. So 0 plus lower limit plus upper limit, 0 plus 10 by 2 you do. So 10 by 2, nothing but 5. So in that way, we'll get the midpoints. So midpoints, notation, take it as x, so that we can go for the formula. So like that, each and every class interval, add up both upper limit and lower limit, you add up, divided by 2 you do, you'll get the mid values. Next, check it out, like 10 plus 20 divided by 2, nothing but 15. Similarly, next one, 20 plus 30 divided by 2, you'll get 25. So like that, up to the last value, 50 to 60, you have to do the mid values. So like for last one, let me explain again. 50 plus 60 divided by 2, nothing but you'll get as 55. So in this way, we'll frame the mid values. So all the mid values we got, midpoints we'll call, and notation is x for that. Now F column we have frequency column, F column, and midpoints column, X column we got. Now make it another column as Fx. So Fx, what we'll do, simply multiply each frequency value with its midpoint value, that is your x value. So 8 into 5, nothing but 40. So 8 5s are. So in that way, we'll multiply second column and third column, we'll get as Fx column. 8 into 5 is 40. Next 10 into 15 you do, you'll get as 150. So in that way, multiply the second column with the third column every time, you'll get the Fx column, each value. Like the next value, 20 into 25, you'll get as 500. So in that way, multiply and get all the values of the Fx column. After obtaining that entire column, add up the data. So 40 plus 150 plus 500 plus 1050 plus 1125 plus 660. Add up one to another, you'll get summation Fx. Summation, I said, adding to one another. So add up all the data, you'll get summation Fx value. Now let us go for the formula of the continuous data, that is x bar is equal to summation Fx by n. Summation Fx, just now we have obtained the last column of the table. That value you substitute over there, that is 3525. You substitute in the formula, divided by capital N. Capital N already we have obtained, that is adding up frequencies, that 105. So 3525 divided by 105 you do, you'll get an answer, x bar is equal to 33.57. So that is your final answer for continuous data in direct method. So now let us discuss next method for obtaining continuous data, that is your shortcut method. So how to do that one, check it out here. Step 1, find the mid values. Mid values, just now we discussed midpoints or mid values, that is lower limit plus upper limit by 2. The same we have to obtain here. First step always will be obtaining the mid values, whatever the method might be. So first mid values obtain, m is equal to, then go for step 2, take assumed mean and calculate deviations from midpoints, denote it as dm or dx. So what you have to do, assumed mean, take assumed mean. Assumed mean I'll explain in the coming example how to take, and then what you have to do, calculate deviations. Deviations also I'll explain in the next example. Now step 3, multiply deviations with respective frequencies and denote it as f dx. So that all we'll be doing now. Now formula becomes this one, x bar is equal to a plus summation f dx by capital N, or a plus summation f dm by capital N, because summation f dx or f dm we are considering, right? So any of the one of the formula we can use. So how to get that assumed mean, how to get the deviations and all, let us check it out using one example. So first example here we have the data, check it out. From the following data, compute arithmetic mean. Same example just now whatever we have done, let us use shortcut method for that and let us obtain the answers to that. So first they have given class intervals, always they specify class intervals and frequencies, we know. So write down that in first two columns, then add up frequencies one to another, 8 plus 10 plus 20 plus 30 plus 25 plus 12, you will get capital N, that is total of frequency we know already. So that you have to add up. Now go for midpoints. Midpoints also just now we have done in direct method, the same as it is, adding upper limit, lower limit to upper limit by 2 is your mid values. Let me once again clarify, lower limit, upper limit, these are the values. Now lower limit is 0 plus upper limit is 10 by 2, you'll get as 5, that is your first midpoint or mid value. Here I am taking it as m, There we have taken an direct method as x, sorry, here midpoint as m I'm considering. So that m value for each and every class interval you obtain. Same formula, lower limit plus upper limit by 2. So all the mid values will frame here. That is your third column. Now let us go for the fourth column. What you have? Formula dx is equal to m minus a. So m, just now we have obtained midpoints, right? Now a is assumed mean. Just now we are in steps we have checked out, right? So assumed mean is nothing but one of the value from the midpoints. So check it out, whatever the values we have, 5, 15, 25, 35, all the values we have, right? So from that pick any one of the value, that is called assumed mean. So better you pick mid value out of that, so that we'll get values, very less values will get. Shortcut method itself will be using to get lesser values, less values, so that calculations will be very easy for us. So if you pick one of the mid value, it will be easy for us. So I'm picking 35. So it's an even data, you can pick 25 or 35. So I'm picking here 35 as my assumed mean. Assuming. So I have assumed 35 as my mean. So now what we have to do is each midpoint, whatever you have, subtract that with our assumed mean. So first value, how to do? 5 minus 35 is your minus 30. So in that way, we'll do dx values. Taking an assumed mean as a and that particular value, subtract it with the midpoints and get a column as dx column. So dx we have obtained just now by taking mean, assumed mean, subtracted with midpoint. Next, f into dx column. So how to do that one? Frequencies already we have, right? That particular frequencies you have to multiply with the dx column. Now 8 into minus 30. 8 into minus 30, 8 is frequency, minus 30 is dx value. 8 into minus 30 you'll get as minus 240. That is your final f dx column. F into dx we are doing. Similarly, go for all other values. 10 into minus 20, you'll get as minus 200. Next 20 into minus 10, minus 200 again. So like that, you'll get all the values in the f dx column. Now add up all the values of the last column, you'll get summation f dx. Summation in the sense adding all the values. So last column you add up, you'll get summation f dx. Now let us go for the formula of a shortcut method. So x bar is equal to a plus summation f dx by n. A just now we discussed, it's an assumed mean, right? That is your 35. So substitute it is 35 plus summation f dx, last column total minus 150 divided by capital N, second column total 105 divided and add up to a, you'll get a x bar value, that is your 33.57. So that is how we'll calculate arithmetic mean for shortcut method. Next, let us go for one more method. So third method we call as step deviation method. In step deviation method, again we'll calculate for continuous data. So how to do that is, first step again is the same, that is obtaining midpoints. Then considering that particular assumed mean and getting dx values or dm values. Then for that we'll have a common factor here. So that we'll discuss in the problem how to do. Then multiplying and all is the same. Check it out the formula now. X bar is equal to a plus summation f d dash m by n into c. So how to obtain? Let us deal that using an example here. So example, again the same example if you consider. For that, let us go for step deviation. So check it out. First column always class intervals, then frequencies you have, then midpoints. We know just now we discussed. So the same midpoints you consider here. Then dx values. Dx also just now we have explained in shortcut method. The same way you consider here m minus a. A again I have taken 35 itself, assumed mean. And I have done dx values, then go for d dash of x. So d dash of x is a new column. Now let us discuss how to do that one. So d dash of x is nothing but take the dx column, whatever you have, m minus a values divided by c you have to do. C is nothing but a common factor, nothing but each and every value, whatever you have, like 30, 20, minus 20, minus 10, 10, 0, 10, 20 you got. No, that is your class intervals. How the class intervals are ranging, 0 to 10 they have class intervals, right? So 0 to 10 class intervals, it's a difference. So upper limit minus lower limit you do, that is your common factor, means how the range is going on between the limits. So every time check it out, 0 to 10 is nothing but c is equal to 10 minus upper limit minus lower limit. Nothing but 10. Now check it out for the second class interval, 10 to 20 you have, 20 minus 10 you do. So you'll get 10 again, right? So how the range is going on, how the difference is there for each class interval is your common factor. Common, how the data is ranging. So 0 to 10, 10 to 20 means 10, 10, 10, 10, 10 differences we got. So that is your C. That value you have to divide here. So M minus A by C. So minus 30 divided by 10 is you will get as minus 3. Similarly, minus 20 divided by 10. Each value of m minus x divided by 10 you do, you will get d dash of x. So that's how we will obtain d dash of x column. Next, finally go for f into d dash of x column. That is frequencies should be multiplied with your last column d dash of x column. Nothing but 8 into minus 3 you do, that is minus 24 you will get. So in this way, we will calculate the last column frequencies multiplied with your f d dash of x values, 8 into minus 3 minus 24. Similarly, go for the next value, 10 multiplied with minus 2 minus 20. Similarly, all frequency values you multiply with d dash of x values and you will get f into d dash of x column. That column you add up one to another, minus 24 minus 20, that all you add up, you will get summation f d dash of x. So that is your last column. Now let us go for the formula substitution. Formula we know already, x bar is equal to a plus summation f d dash of x by n into c we have. Now let us go for the substitution. A is assumed mean we know already, that is 35 we have taken. So substitute that, 35 plus summation f d dash of x is last column total. Substitute over there, divided by capital N is the second column total, 105 into c. C just now we have explained like difference of upper limit minus lower limit 10 we got, right? That 10 you have to multiply here. So go for the calc and calculate all these values. You'll get x bar as 33.57. So this is how we'll calculate mean, arithmetic mean in step deviation method.